Hi, good afternoon. Welcome to the second session in the Synoikis Digital Classics Spring 2025 program. This session, which is on preparing texts and data cleaning, this session very much follows on from last week's session, which was on finding free and open texts, is going to be run again by three different people. Firstly, our colleague Jonathan Blaney from Cambridge Digital Humanities, myself, Gabriel Bodard at University of London, and Katie Shields at King's College London are going to talk about various aspects of this session. The main part of this session is going to be the beginnings of a tutorial in the use of regular expressions, which is the main easy to learn tool that we use for basically find and replace in complex ways, which are used for cleaning texts of various kinds. Yes, just wanted to say hi and welcome to everybody who's watching us live. If you're watching us live from wherever in the world you are, please use the live chat on the right-hand side of the YouTube video to say hi. If you're not coming from this as part of an organized class, you may be interested to find the link to the session page for this session, which you will find in the description beneath the YouTube video. This will have some suggested readings, other resources, and also an exercise that we're going to sort of point to in this session. It's all on that page. Also, hi to anyone who's watching this later in time. We're delighted that people continue to use this resource. If you are watching live, also feel free to use live chat to ask any questions that come up during the session, and we'll see them on the side there, and we'll try to respond to them. And any questions and contributions and comments at the end of the session. In particular, we'll have discussion then between us and between, I hope, all of you. I think that's it for general introduction. The session is going to start with a recap of why we need to do text cleaning and a bit of a discussion of the sorts of things that we can do in terms of text cleaning. Not all of which we're going to talk about today, but Katie, do you want to start us off in that area?
Great. So first off, then I'll be talking about what text cleaning is, why we might need to clean texts. Text cleaning is basically removing noise from a text to analyze the text, to do something with the text. So that might be things like removing errors from your text, whether that's things like typographical errors or perhaps OCR introduced errors, depending on the sort of text that you're working with. Things that are wrong, that might in some way cause some problems for your for analysis that you're trying to do. The other sort of noise that you might be removing is metadata. As we talked about last week in the previous session in this series, most digitized texts often come with some data that's about the text, but not necessarily part of the text itself. So things like line numbers in a poem or page numbers in a book that might have ended up in your digitized text, but you don't want to analyze the line numbers, you don't want to analyze the page numbers, you might need to remove them. Basically removing any noise from a text for analysis, removing any element that's either outside of the text or not relevant or not suitable for the sort of analysis that you want to do, or the type of tools that you want to do to carry out whatever task you want to do with the text. Obviously, this text cleaning is a significant part of any project working on digitizing or digitized text. This pre-processing of the data is very, very important, because to do good analysis with your text, you need good data, and you need data that's specific to the task that you're going to do. So how to clean your data depends on what you want to do with it. You do sort of have to know what sort of questions that you're trying to ask, to know what sort of clean text that you want, and what sort of tools that you want to use it with. Obviously, if you have a text that's full of OCR errors that have led to a lot of misspelled words, if you want to count how many of a particular word there are in a text, then you'll miss all the ones that are misspelled that have a typo in them. Or if you want to find every time a number is written in Arabic numerals rather than written out in the specific language that your text is in, then having things like line numbers or page numbers in there that might be in Arabic numerals but aren't actually part of the text is going to skew your results quite a lot. So you need to have some idea already probably of what you want to do with the text, what sort of questions that you want to ask about it before you clean it. And again, removing the metadata like page numbers and like line numbers might be quite important for that sort of analysis. But also, once you've lost the metadata in the text, that might make other sorts of analysis more difficult to do. So you have to sort of know what you're doing with it before you remove the noise. You have to know what's noise or not. So I've got some examples here of what sort of noise you might want to remove from a text, and some problems that you might come across with cleaning text to use for particular tools with one of the Nabonidus cylinders. So this text on the screen now is a composite version of the Nabonidus cylinder 1. And you can see on here that this page has the text itself in the middle. There's various other information about the text to the left of it, and there's a translation to the right. So if I wanted to look at just the text itself, there are already some things in here to note to be careful of that are bits that I might need to remove if I wanted to do something with the text, including, for example, the line numbers. So down the left, each line is labeled with the column and with the line number. So 1, for example, in the top left. There's also a footnote, which is the second red box down on the right with a number 1. So that's a note. That's something else that isn't part of the text itself, indicated with the note. And there are also things that you might want to be careful of with regards to the formatting of the what's in the text itself. And you have to sort of know the text that you're working with and know what you're going to use them for to do that. So towards the top right, there's a little red box around a superscript d, and the fact that it's superscript lowercase d tells me that this is a determinative. This is a classifier. That the following thing is a God's name. I know what sign that represents on the tablet, but also I know, because it's written lowercase superscript Dingir, D, that someone has interpreted this as a determinative, as a classifier for a God's name. And it's the formatting, in fact, of the text that tells me this, and that's something that you might easily lose with just copying and pasting, for example. And there are these other further down notes. Here I've got another divine name with a determinative, but also the fact that some of it is uppercase and some of it is lowercase, and that it's separated by a dot and separated by a dash. Also gives you information about the writing. And I've also got a number here written subscript, and that's to do with the reading of a particular sign. So that's giving me information about the spelling of this word, rather than because it's written subscript, rather than being a number, as in like an actual number. So these are all the sorts of things that I might be thinking about if I wanted to prepare this text to do some sort of analysis, some sort of visualization with it. So when I've just copied and pasted this text straight from that page, I've got here still the line numbers. I've got here the translation for the whole first paragraph after the first line, and I've lost some of the information because this determinative here is no longer written superscript. So if I wanted to do something like part of speech tagging or lemmatization or something of this text, there are some things here that I might
Looks like we've momentarily lost Katie there. Let's give her a few seconds to see if her internet connection recovers. If not, maybe we should move on to the next section where Jonathan's going to give us a quick introduction to what regex is, and then when Katie comes back, we can.
Yeah, should we do that, Gabby? Because the two, we could have done them in either order, I think, couldn't we?
Indeed, yes, very good, cool, great, thanks, Jonathan.
Okay, so well, Katie was in the middle of a really good practical demonstration of what regular expressions are, and that is the way I think to really to learn them. The term is a bit misleading because it's from mathematics, but it doesn't really, looking up the origin of that, certainly for me, doesn't help me understand what they are. What they are really is a kind of supercharged find and replace. So instead of the standard find and replace that you've all done many times in an editor where you find a literal list of characters and replace them with a literal list of characters, you can use patterns for both the find and the replace, which is extremely powerful. It's quite a simple idea. And it's quite a simple syntax, as Gabby's going to demonstrate shortly, but it's actually really powerful and they can become quite complex. An example I like to give of what that means in real life is if you've ever filled in a web form where you're asked for an email address and you start typing your email address with some, alphanumeric characters, and you immediately get a pop-up saying this doesn't look like an email address, something annoying like that. How does the program know that it's not a valid email address? Because it, of course, can't look up every possible email address on the planet, even if such a list existed. And it's doing that, I imagine, via regular expressions, or certainly you can check whether something is an email address by using regular expressions. So it has many uses. The find part, and Katie was alluding to this a minute ago, is very useful for things like counting things, occurrences of things which may vary within a text or set of texts, but which you know roughly what the patterns are, the patterns of the varying might be. And the other thing you can do is find things that come, say, after other things or before other things. To give a concrete example of that, I taught a class on regular expressions in the autumn, where we were using 6 Jane Austen novels, and I was getting the class to find the words that come after names of characters, like, for example, Anne Elliot in Jane Austen's last novel, Persuasion. So we would search for the word Anne, and then we'd find the word after Anne. And then if you want to, you could then say, give me all the words after Anne which end in ED. And these are, very roughly speaking, very crudely speaking, Anne's verbs, because the novel's written in the past tense. Doesn't include all the verbs, of course, things like thought Many English verbs don't end in ed, but lots do. And then you can look at that set and find out what are the most frequently used verbs by Anne Elliot, with those caveats about the crudeness of that approach. But you can see how that can generalize. And the replace part, as Katie was also saying, is really useful for cleaning and preparing text. There's often lots of stuff you want to take out, but it's not literal strings that you know in advance exactly what they'll be, or there may be hundreds of them that you don't have time practically to go through one by one. And also replace is quite general in the sense that you can move parts of things around. You can find a bit that's followed by something else and then swap them, or something earlier in a text and move it to later, that kind of thing. So that's very powerful. I'm not going to give an example in my demo. I don't know if Gabby or Katie will, of exactly that. But in the exercises, I've put an exercise on the GitHub, which asks you to try and do that with some names in a text I'll show you shortly. And I've put at the bottom, they don't do anything else because they don't do things like calculations. So you can find digits in a text. And Katie, I think, was just talking about finding Arabic numbers, but you can't then do any calculations on those numbers. That's not what regex does. It has a very specific role. It finds strings of characters and replaces strings of characters. It's sometimes called a domain-specific language because it has a very specific thing that it does, or a little language because it doesn't do very much. DSLs and little languages are kind of synonyms. And you can sometimes get a bit confused if you think, for example, that with regex you're finding numbers. Numbers are not what regex finds, because numbers are a concept it doesn't have. It will find a sequence of digits, one digit followed by another. That's not the same as a number as far as regex is concerned. You can't find a number and then multiply it by 10, for example. But combined with a programming language, of course, you can find the numbers, and then using other elements of the programming language, you can do more kind of programmatic things. Why learn them? Gabby already said they're quite easy to learn, which is right. They start off very simple, although they get complex. And they are almost ubiquitous in any text editing software. I put almost in brackets because Microsoft Word most notoriously has its own very, inadequate version of regular expressions in the find and replace. It's called pattern match. It's not at all the same thing. It's a very kind of diluted version. And it's a shame because I think more people would have learned regex as they were growing up, going through school using Word if they had Microsoft had added standard regex. But almost everything else has them. Almost any programming language you're likely to learn has regular expressions. And they're almost, once you've learned them once, essentially you've learned them for everything. There are very small differences. I've got an example later, but you can easily cope with that. If you know regular expressions, if you know there's a slight variation between two dialects, it's very tiny and you can easily work around it and get used to it. And they're great to learn because I've put modular here. I didn't really know how to express this, but anything you learn doesn't depend on other things. So if you remember a couple of things that we show you today, you can still use those independently of all the others. If there's just a few things that you take from this, you can use those and then add more as you go. There's not a learning curve in that sense of there's things that you need to know before you know the other things. And as Gabby's going to show very shortly, the basic syntax is really minimal. The things that you need often are very, very few. I used to teach this in the days when I gave out physical handouts with a sheet of A4 with all the regex you'll probably ever need in your life. But they do get complex. And for that, the only secret is to practice and to use them firstly on texts that you're interested in, because if you're just doing them as exercises on text you don't care about, you won't kind of see the great attraction. And my second bit of advice on learning regex is to start very small with a very minimal regular expression, rather than the temptation, which is to go straight into a complex expression that you think you can write. I sometimes do this myself and it doesn't work, and then you can't quite see from this string of characters where the bug is. So it's always best to start very simply, match some small thing, and then keep incrementing until it matches everything you need, and then do the replace step. So that's all I've got on regex. So I'll hand back to Gabby or to Katie if she's back.
Yes, looks like Katie is back. Yeah. So yeah, I think we got the gist of what you were saying about the things you might want to remove or replace or otherwise fix in Hittite. Katie, you had I think a final slide about text cleaning approaches. You were going to use. You'll need to reshare your screen.
Oh, yes. Sorry. Here we go. So, yeah. So, apologies. Eduring kicked me out while I was in the middle of talking about the things that I might want to remove from this Akkadian text. So in the further slides, which are linked but which I won't go through, there is an example of this text after I'd removed some of those things from it, and I did that with a combination of doing things by hand and with some simple regular expressions. Obviously, if you've got a very short text or something very small, you can clean your text by hand, but manually going through and removing every line number for a text which is hundreds of lines long is rather tedious and not very practical. There are some sort of very basic free online tools for cleaning texts where you can copy and paste something into a website and then use a number of like preset options to do things like convert all letters to lowercase, remove all punctuation, or some very simple find and replace things. These are good if you only need to do very simple things, and many of them are in fact basically using regular expressions syntax anyway, but if you want to do something more complex, that's no good, and also you're sharing your data with, you're putting your data into one of these websites, you might not necessarily want to do that. You could perhaps ask AI to clean your texts, but AI is very good at doing things with large amounts of data. You can ask AI tools to do complex things in relatively plain language, but how would you check that an AI tool had cleaned your text correctly? You'd probably want to, check that it had done the things that you'd asked, and you'd probably want to use something like regular expressions anyway. In general, I think people are not very optimistic about the use of AI for text cleaning, that if you really wanted to use it somehow, you'd be better off asking it to help you write your regular expressions or something like that. So the conclusion of this is that actually probably regular expressions are the most useful way to clean up your data that you'll probably want to go to use most of the time. And we're going to show you how you can do all of these, remove all these things, change all of these things with regular expressions. Great, and I'll hand back over to Gabby to talk about regular expression syntax.
Great, thanks, Katie. Yeah. So yeah, I mean the first. Let me just check if I can share the right screen. Yeah. So the first thing to say about regular expressions is that although this is, as John says, this is a programming language, it's very easy to learn programming language, and it's we're really only going to scratch the surface of it in this session. What we suggest, and it's for our students, it's more than a suggestion, but for people who are following this out of personal interest, what we suggest is that there's an online tutorial on regular expressions at the Programming Historian site. And we've linked to that in the session page, which again is below this video. We suggest you work through that, and you will get everything we're showing you today. But also you can go further. You can go as much further as you like. Because regular expressions are pretty ubiquitous, you can use almost any tool you want to use them. We're suggesting you use Visual Studio Code. That's simply because that's a tool we're going to use in some other sessions as well. It has plugins for XML, which we're doing in a couple of weeks, and other things. But you could use pretty much any tool, except, as Jonathan says, not Microsoft Word. You can do probably most of what we're covering in the sort of basic regular expressions today using Microsoft Word, but because the syntax is different, it won't help you in terms of using it in anywhere else. So we recommend you don't bother to use any other tool in the world than that, probably. So Jonathan mentioned a one-page sort of handout on regular expressions, which gives you literally everything you would possibly need to learn. This page, which is linked in the slides for the regular expressions cheat sheet, which you can find online. This is one such handout. It is more than you could want to know. About half of what's on this page, I don't know what it is, and I don't consider myself, a beginner in regular expressions. So pretty much what's on the screen now is almost all of what you will want to know in terms of regular expressions for the purposes of this exercise that we're talking about today. I'm going to divide the basic syntax that I talk about into what I think of as selectors. There's groups and ranges here, and as quantifiers. And we'll talk about replacement a little bit more in the examples, which Jonathan's going to lead in a minute. But basically, the simplest selector, the very simplest selector is just a letter, right? If I say A, it will find an A, or it'll find all the A's in your text. That's sometimes what you want, where you could have a word you could spell out or whatever. But it's not very flexible. It's not the power that regular expressions brings. The powerful thing is when you have a selector which is like a wildcard, as some languages call it. And the basic wildcard character is this. It's the full stop character. It's the dot given here. So it's any character except in most cases not a new line character. So regular expressions tend to work sort of within one line at a time as you go. So if I say find me dot, it won't find me just all the full stops in my text. It'll find me any character in the text, which is quite powerful, but it's clearly much too general, as it will find me everything. But it's the basic building block of many regular expressions. You can also specify using square brackets a range of characters. That's here's a few examples of this, where you can either just list in the square brackets all the characters you want to include in your range. You can make it a negative range by beginning the range with this caret character, which says I'm finding any characters except those. Or the other useful thing you can do is you can use a range of characters with a hyphen in there. Bear in mind that the regular expressions are case sensitive, so if I say I want to find all the letters from A to Z and I only put it in lowercase, it won't find me uppercase letters in that. This is useful if you want to find all the letters in a particular range, in a particular alphabet, etc. And I'll have an example showing you how to do this with ancient Greek a bit later. And it's useful for digits. You can say find me 0 to 9. That'll find digits in that context. So that range is potentially a useful thing to do in square brackets. So once you've got your selector, whether that's a range or a wildcard or indeed a specified character, the thing you want to do that you want to apply a quantifier to that. You're either finding it just once, in which case you don't need any quantifier, or these are the most useful quantifiers that we have in regular expressions over here in the middle column. The basic quantifier is the asterisk character. This means find this expression whether or not the preceding character is present. So 0 or more times, in other words. So if I say, find ABC asterisk, say find AB whether it's followed by 0 or 1 or 200 C's. The plus character might be slightly more useful than that sometimes, is you want to find the character at least once, but possibly more than once. The question mark is a slightly less powerful version of the asterisk. It says find this whether this character is there or not, but don't worry about it being there more than once. We're only interested in it appearing once. And if you want something that's other than 0 or more, 1 or more, or 0 or 1, then you can define your own quantifier with a curly brace, and you can put numbers inside that curly brace. You can say either find it 3 times by just putting the number. You can say find it between 3 and 5 times, 3, 5. Or if you say 3, and then leave it blank, that means any number above 3 times. Okay, so the easiest way to explain how these quantifiers work is with some examples. So I will switch over to a test site now. I'll just point to two other things just very quickly. And these are character classes down here. These are particularly useful, not because I'm going to talk about them now, but because other people might talk about them in a minute, and I'm certainly going to talk about them a bit later. These are things like \d, which in combination means any digit, and \w, which means any alphabetic character, any character that's part of a word. Those are things which we'll see a bit later how they work. And I'll say one more thing about the \. Backslash followed by something is usually some sort of special character like this. There's various other things that are not character classes that also are constructed by having a \/ followed by a letter. Backslash can also be used if you want, for example, to look for a question mark character in your text. Question mark has a special value. It's a quantifier, meaning the previous character 0 or more times. But if you want to find the question mark itself, rather than using it as a quantifier, you can precede it with a \ character. \ question mark means a literal question mark. Same with an asterisk, a plus, curly brackets, square brackets, anything else that has a special meaning in regular expressions. If you want that actual character, you can precede it with a \ and it will appear, including a \. If you want to search for a \, you just type 2 backslashes. So those are the basic things that should cover the things that I'm going to show now, and then we'll have some more detailed expressions. So just to explain the very basics of what we've said. When I said that the full stop character means any character, as you can see, I type a full stop. This is my text. I've just got a random XML file I've selected in here. I type a \. Every character in this text has been matched by the dot character. Okay, because it just means any character. If I were to type \dot, it's only finding the dots, the full stops in this character. Just to quickly show how groups and ranges work. If I type opening and closing square brackets with all the vowels inside, it finds all the vowels in my text. And again, it's finding them one at a time. It becomes useful when I say, find me any string of 1 or more vowels, so any vowel 1 or more times with the plus there. Then you see a few of these matches are 2 vowels come together. Those 2 vowels EI, there's 2 vowels EA down here. And if I say, find me anything that's 3 vowels or more, there's only 1 in the document somewhere down here. Yes, the word previous has 3 vowels in a row in it. Okay, so it's finding any character in that group the number of times specified by the quantifier. This is I'm not sure if there's anything else that'd be useful to sort of show. Is there? I guess I can talk about the range. Find me any of the characters A to E, any of the first 5 characters in the alphabet. Find it me 1 or more times. So how many long strings can we get that are only made up of the first 5 characters in the alphabet? It looks like there's strings of 3 characters, might be the longest we find in there. It's not a terribly interesting search. So there's 4 here in the middle of the word header. There's 4 things, but it's that you can start to find sort of strings of characters in there. I'll quickly. I mean, is this something you're going to talk about, Jonathan, or shall I quickly show the concept of greedy and non-greedy?
I don't have greedy and non-greedy actually, Gabby. So if you could do that, that would be great.
Okay. So by default, a regular expression will find the longest expression that matches the longest result of text that matches your expression. In other words, when I said find me one or more of the first 5 characters in the alphabet, when it come to this one, it could have stopped after A because it's found one or more. 1 is one or more. But instead, because it can match 3, it matches all 3, right? Because 3 is the longest string of 1 or more in that instance. If I take the change the selector from the quantifier from being plus to being plus question mark is a quantifier in itself, and that means find me the shortest possible match to this. And so in that case, 1 or more means 1, right? So A. Well, let's see. I mean, if I'd said find me, I mean, that sounds. In this instance, it's such a simple regular expression that it's not terribly useful because that in practice is exactly the same as me just saying find me the thing without any selector at all. But it becomes useful when you've got more complex expressions where it's followed by something. You might need to find 3 instances of it before you get the thing that you want it to be followed by. So it is still the shortest possible version with more than 1 in there. And so an example of that, this is something you might well want to do if you're cleaning a text. You've got this XML file and you want to clean it to turn it into plain text. This is not actually the best way to turn an XML file into plain text, but let's just, for the sake of argument, let's say you've decided that you're going to find any string which is an angle bracket followed by some text, followed by a closing angle bracket, and you're going to remove that piece of text, and what you'll be left with is everything that's not an XML tag. Okay, so the regular expression for that, I'll say open angle bracket, dot for any character, plus, because that character's got to be there at least once, but could be there many times, followed by another angle bracket. That will find me every XML tag, right? If you look at what's on this screen, and I will zoom this in a little bit, make this a little bit easier to see. If you look at the results on this screen, you may see, and if you don't immediately see it, you might want to pause the video and stare at it until you can see it, because I'm about to explain to you why this hasn't quite worked. For this example, TI header, angle bracket, TI header, close angle bracket, it's the only text on this line. It has found what we were looking for and what we want to remove. This 4th line here, however, open angle bracket, title, close angle bracket, but it hasn't stopped finding it because later in this line, there's another XML tag which ends with an angle bracket. So the greedy search result, which is what these quantifiers do by default, remember, is to find everything from this first opening angle bracket to this last closing angle bracket, which includes a bunch of text in between, which is not XML tags, therefore we didn't want to delete it. Okay, so it's found too much because I've designed this regular expression to be greedy when it shouldn't be. So if I make that non-greedy by just adding a question mark after the plus, it's now only finding the tags. It finds an open angle bracket followed by anything inside up to the first close angle bracket it finds. And that will only find the XML tags. And note it'll find the XML tags whether they're opening tags like this, closing tags with a slash character, or opening tags with attributes. It'll find the entire thing, it'll remove it. If I say, find this regular expression and replace it with nothing, all the XML tags will be gone from this file. Now, that's not the most useful way to turn an XML file into something that you can use for text processing, but it's a start, right, in terms of things. So that's just an illustration of what we might want to use greedy versus non-greedy quantifiers for. So I'll stop there, and we'll have more. Jonathan's going to give us a few more examples, and then Katie and I will give a very brief example each at the a bit later. And over to Jonathan.
Okay, thanks, Gabby. That was a really good explanation. And I'll just try and really, it's just consolidating that with some examples from this file that you can see on screen. We're now using VS Code, Visual Studio Code, which is the recommended editor for this series. But as Gabby said, if you already have an editor that you like, that you use, there's absolutely no reason why you can't use that, because as we've said a few times already, you can use regex in essentially any text piece of software. If it doesn't have regular expression support, that's probably a bad sign for how good it is. But we're choosing VS Code because it's cross-platform, it's free, it's very well supported because it's very widely used, and there are many plugins. Gabby mentioned the XML one, and there are thousands of them that can make your life easier with whatever you're doing with text. So this file I've got here, which is also on the GitHub for you to download if you want to try this out, is a .bib file. I don't want you to worry at all about what that is. It's a BibTeX file, but I've chosen it not because we're interested in LaTeX or BibTeX or any of those things today, which we're not, but just because it's in columns, so we can actually see what's going on quite easily, whereas with running text, with big paragraphs, it can be harder to see what's changing and what's not. And also because VS Code recognizes the .bib file termination as one of the ones it can do syntax highlighting for, it gives us a bit of, the blue and yellow and red that you can see there, help us see what's going on with the structure. And then finally, because I wanted to emphasize that you can use regular expressions on all kinds of types of text, it doesn't have to be plain text, doesn't have to be XML, there's all kinds of uses for it. So, but the actual content itself, you don't need to worry about. So let's try and clean up this text a little bit using regular expressions. So to start with, the first thing I want to do, you can probably see that at the end of every line there's a comma. I want to remove that, but you may also see, if you look at, for example, book title in line 3, that there are commas throughout, which we don't want to remove, parts of the abstract parts of the book title and so on. So I'll do the find and replace. It's just highlighting all the A's there. And in VS Code and in every editor that I know of, every text editor I know of, you just use the find and replace usual menu, but you switch it into being regex somehow. Sometimes there's a checkbox. In VS Code, it's this dot star here, which is the dot that Gabby showed you, and the star meaning 0 or more. And it's often the symbol that people use on menus for regular expressions. So that's turned on for me. So I can now use regular expressions straight away. So I might just move that a little bit if I can. Oops, that's not very good. Okay, well, I have to leave it. I think I split the screen. Sorry. I'm not used to using VS Code. Okay, that's better. So I want to find the commas at the end of every line, but I don't want the commas in the middle. So I'll do a comma, which is then immediately matching everything, as Gabby showed you earlier. I don't want all those, so I'll use a dollar, which was the line anchor Gabby showed you earlier. It finds only the ones at the end of the line. And then all I need to do is replace that with nothing, just like you would delete things from the text, and they're gone. So the next thing I want to do is to do the opposite, which is I want to delete in line 10 and line 21. You can see these curly brackets on their own. And I want to delete those only when they are the first thing on the line. So what I'll do here is use the other line anchor that Gabby mentioned. So dollar is the end of the line. The caret or the circumflex is the beginning of the line. You can see without anything, it's finding all the beginnings of the line in the text. Now, if I just type curly bracket, it won't allow me to do that because this is one of the special characters in regular expression. So we're going to need to escape it with the backslash that Gabby showed you. So if I do that now, you can see it's only matching the ones at the beginning of the line. And because I don't know this text that well, I don't know what's in it, I'm going to be a bit cautious, and I'm going to put a dollar in as well. And that constrains it to matching only lines that simply consist of a closing curly bracket. So what we're saying is beginning of the line, closing curly bracket, end of line, and that's all it's going to match. In general, I think it's good to be conservative with regular expressions. Quite often in big texts and texts you don't know very well, you end up deleting things that you didn't realize you were going to delete. And sometimes you may not know that until quite a lot later. So I think be as conservative as you can when trying to match things. So constrain your matches as much as you can. So that's the most constrained I can do that, and I can replace all of those. And I think you can also see from that, if I wanted to match empty lines, I can just do caret and then dollar. So that means a line with no character in it at all. Beginning of a line immediately followed by the end of the line. I won't do anything with that, but that's sometimes something useful to be able to find. So being a bit more interventionist now, these abstracts are very long, and I'm not interested in the abstracts, so I'm going to delete the lines that begin with abstract. So we will start with find the beginning of the line and then just the literal word abstract, which you can see is being matched. And now we want to delete the rest of the line as well. And that's the dot character, that universal character that Gabby said matches any character. And if I keep doing dots, again, you'll see it's matching, matching, matching. But of course, the lines are of different lengths. This is where I need a quantifier to tell me how many. And here I want one or more. In other words, keep going until you don't find a character. So if I do that, that is going to give me all the lines of the abstract, however long they are. And if I just put $1 on at the end, just to make sure, I don't really need that, I don't think, but I'll put it there for safety anyway. And then I can replace all. Again, I'm just leaving nothing in the replace box. I'm going to hit that replace all, and they have gone as well. So you can see now how powerful that is. You can delete an enormous amount of text. If you're trying to clean things up, this is going to be really fast. And regexes are fast, even on very large amounts of text. I've run them on gigabytes of text before, and they've worked really quickly. So the next thing I want to do is to shorten one of these, which is the keywords. You can see that it goes on, they're quite long. I want to trim this down to a certain length. So again, I'm going to type literal beginning of the string keywords, beginning of the line keywords. And then I'm going to do dot. And this time, this is a little bit arbitrary, but I'm going to use the curly brackets, which give you your own exact quantification. So what I'll do is I'll say 30 characters. So now I'm matching up to 30 characters in the line. I'm going to delete the rest of the line. So I need to include that in the find. And that's, as we saw a minute ago, that's dot plus dollar. But I only want to keep in the replacement the first bit up to the 30 characters. I don't want or care about this bit here, dot plus dollar. That's all the other characters in the line. So what I need to do is to mark the bit I want to remember. This is called a capture group in regular expressions with round brackets. So here I'm going to put, it's telling me it's not valid because I don't have the first one, but when I put that in. So this is now dividing my find up into two parts. The part inside the round brackets, which is the bit I want to keep, and the part outside the round brackets, which I don't want to keep. And in the replacement, I just refer back to the part in the round brackets. And you do that with dollar, and then it's the order, the number is the order of the sets of brackets that we have in our find expression. In this case, I've only got one, so it's $1. You can sometimes have up to 4 or 5 in a really complex expression, but I think if you have more than that, then you probably need to think again about how you're doing it, because they can get really complex. But 1, 2, or 3 capture groups is quite common. So hopefully if I now delete or replace all, you can see that it's deleted up to 30 characters. I've kept up to 30 characters on that line, including, no, not including keywords. I could have put in by just putting, in fact, let me undo that. Because I want to keep the closing curly bracket there, I'll just type it in as in my replacement expression and do that again. Notice that I didn't have to escape the curly bracket in the replacement. That's because almost no characters are special in replacement. So things like a full stop, a caret, all the things you've seen already, square brackets, are not special in replacement syntax, so you can just type them in. The main one that is special is the dollar that I'm using there. There are not very many of them, so that makes things easier.
And of course, dollar has a different meaning than it does in the find box.
Yeah, yeah. There's a couple. There are a couple which are overloaded in the sense they have several meanings. The caret is one. I'm going to show you in a second, and dollar is another one. It means end of the line or replacement. My capture group 1, capture group 2, and so on.
I can just interrupt for a moment. Sorry, I know I just did, but this is a good moment because you just showed it, but you didn't explain what you were doing. Sarah just asked in the chat, what do you do if you make a mistake in the regex and you want to go a step backwards? And there's two possible answers to this. I think one is what you did, and another is more complicated. I don't know if you want to speak to that briefly.
Yeah, I think you can undo, as I just did, because this is a text editor. So using it here, we can undo as long as it will let us undo any changes we've made.
It's just Control Z like in every application. Right?
Yeah, I was using Command Z here on this Mac, but yes, it's a good question. The other thing I would say is I mentioned a couple of minutes ago that sometimes, and I've done this many times, you run a regex across a really big set of texts and you find out months later that you deleted some really key data that you need, or weeks later, or at some point you realize. So this is where I would say, I don't know what you were going to suggest, Gabby, that version control is really your friend. If you're running regex or doing cleaning on texts which you really need to be able to wind back the clock by a day or a week or however long, then version control using Git is the way that I would recommend you do it. Is that what you would have said, Gabby?
Yeah, what I was going to suggest as the other sort of answer is sort of related to your later example that you're going to do, showing us an example of using regex in a Python notebook, where if rather than doing this one, changing it, saving your results, doing another, changing it, saving your results, you've got a list of 20 regexes that you're going to run on this text, and you run it, see how it all works, and you can change it. You don't delete the original. You save the result in a different place, and therefore you can change your script with all your regexes in. That's the sort of the more that's the result that we would mostly use if we were doing this for an important project. But if you're going through and you've changed something you don't want to, you can go backwards with Command Z to replace that. If you notice 5 steps later, you can press Command Z 5 times. You then have to redo the other 4 things you did in between, which can be a pain. But
I certainly used to create backups when I was working on a sets of text over time. I would create dated backups so that if I really found out that I did something in June, that I can then go back to May's version or something like that. So it does get complex because the point of regular expressions is to be able to do things powerfully and on lots of text, but the trade-off there is that you often don't quite know what you've done unless you know the text really, really well. But often you're a little bit in the dark, and you want some mechanism of being able to get back. And certainly keeping the original, I'm sure is a standard thing that you would do in your project, and probably at some key stages you would have backups of your texts.
Thanks a lot, Tom.
And thanks for the question. That was a really good one. Okay, I've got 2 more of these before I hand over to somebody else. You notice that we have dates in the year values here. And the ISO standard for dates is to have the YYYY, year, and then to have a month in 2 digits, and then a hyphenated, and then another 2 digits for the day of the month. And I've worked on quite a lot of projects where we've put in a kind of arbitrary 0101 because we don't know the date or the month of the year. Onto the end, and this is a classic thing you do with regex because of course we can't, we don't know what all the dates are, and they change. So I'll next add those ISO dates into those dates. The first thing I'll do is find. I'm going to use this one. Gabby also showed \D, which will do digits, but I prefer 0 to 9. And you can see now that I'm matching a literal curly bracket and then the first number that comes after that curly bracket. And then I can't use the plus because it's going to give me the ISBNs as well, at least in some cases, which I don't want to match. So here's another case where I want to use the numeric quantifier of 4. And then when I do the closing curly brackets, that should just give me the dates. I know that I'm very lucky here because I'm using very simple dates where, you know, we don't have dates that are fewer than 4 digits. We don't have all kinds of complexities that you get with historical dates. But in this case, it's a nice simple one. We can just match 4 digits inside curly brackets, and that's all there is inside the curly brackets. And then again, I want to remember everything, but I'm going to do the round brackets this inside and just remember the number. You could do this both ways, but I tend to not put things like that in. So you can see that I'm matching everything, but I'm only remembering the number in the middle, which is the $1 again. And what I want to do now is just literally type in the curly brackets. I could have remembered the whole thing, but for some reason I don't like doing that. So I'm going to do $1, and then that's just a literal 01-01, and then a literal curly bracket because it's in the replacement box. And hopefully that will work. Yeah, so you can see whatever the year, it's added 0101. And that's quite a powerful thing you can do where you're not actually changing the text in these cases. You're kind of annotating or adding to it or making it in some way more explicit, however you need to work. And then the last thing I want to do is probably the most complex one, which is these title lines. There's also a book title which only has the title, but title for some reason in BibTeX has a / and then the author's name, which I don't want. So I want to just delete the author's name and keep the final, you can't see it here, but the final curly bracket at the end. So this is the most complex one because we have to do this in 2 bits. But it gives me the chance to show what Gabby was showing earlier with the negated character class, where you say anything that's not these, which is a really powerful thing, and which is something I want to show you because I use it all the time. So we've got 2 uses of the caret here as well. Another one of those overloaded characters. So we'll match the bit, and then
nice. Lost him again. So we lost you a couple of times there, Jonathan. You might go back to the beginning of explaining the regex.
Okay, let me delete this and go back. Thanks, Gabby. I didn't realise.
Thank you.
I can only see my screen, so I'm just talking away to myself. Okay, so the last thing I want to do is to match in this title line up to this / before the name, and then delete that and everything after it. And
no, clearly the internet gods are not loving us today. I don't know if you can hear us.
And put back in the curly bracket. So delete the name. It's strange because my internet connection is okay. Can you hear me now, Gabby?
You can now. Yes, you're back now.
Okay. Hope my internet connection seems to be all right. So I don't know if it's a StreamYard or what, but
it might be.
Okay, I'll start again. I'll start again on.
Start typing in the find box again. That's where we got to.
Okay, great. So I'm going to do caret for the beginning of the line, literal title equals, and then a literal. This is all literal because I like to use literal as much as possible. And then we have a negated character class where you use the caret at the beginning to mean anything which is not this in this set of things. And so what that means is, and I'll do a plus, what that means is find me any character which is not a /. And then I will find the literal thing that I want to find, which is the space and the actual /. And then I still need to go to the end of the line. Dot plus dollar. You can see how regular expressions become complicated just for this example. So this is matching the whole line in two parts. If I put in my capture group for the first part, it needs to go there. And now I'll get that first part, and as I did earlier, I'll just add on the missing, I'm deleting and then the final curly bracket there. So if I replace this, hopefully, yeah, that's worked. So this is the most complicated one I'm going to show because it's quite a nice example of, even though it's not that complex, it's quite hard to read. It's actually easier to write these yourself and add them than it is to watch somebody else or read someone else's regex. So hopefully, if you you stay with me in terms of internet connection, that's the end of this bit. And I'll hand over to, I think it's Gabby now, to talk about Greek.
Yes, thanks. And an interesting note about that last thing, I don't think we should go into this, but you could have expressed that same, that whole last, sorry, if you can put your VSC back on just for a second. That regular expression, you could have expressed that, and some people would think it was simpler to do this without using a negation at all, but just using a non-greedy or a greedy match for any characters followed by a slash, because then the first slash you find is going to stop that string of characters, right?
A non-greedy, yeah, you could do that, and I think it is exactly the same thing. I like this negated class.
Yeah, me too. I feel slightly safer doing it because I know what I'm looking for.
And it's a nice one to show people because it's just so super useful and good to know about.
Yeah. But yes, thank you. I'll switch back to my screen and let me just make this a little bit bigger again. And not quite that big. I hope this is so. I'm just going back to the same XML file. I'm just going to do some different searches here. This is actually related to that point of there being more than one way you can do things. Jonathan just showed using this string square bracket 0 to 9 rather than using \d to match any digit. According to this. According to the regular expression 101 tester, if I type in \d as an explanation of what that means over here, it says this means exactly the same as square bracket 0 to 9, which I think it probably does, in at least if it's assuming the Latin character set. There may be contexts in which it means something different, or it may give you slightly less control. But I tend to prefer to use things like the range 0 to 9 as well. But this is something that it can this can sort of help you to understand what's going on. And in some expressions, having /d's in there, if I wanted to say between 3 and 11 characters, that sort of thing, it's it ends up doing yourself a bit of a favor by using a named expression rather than a range that you've defined yourself. I just wanted to say that as a sort of prefix to my main point, which bearing in mind that this point is going the direction of if we're using regular expressions to process texts that are in Unicode Greek. Another useful expression in regular expressions is this \w, which means any word character. So any character which can be part of a word, which it defines as an alphabetic character, a numeric character, or the underscore character for some reason. And that's fine. You can see what it's matching down here. It'd be easier for you to see what's matching if I put in a plus, because it's now finding strings, the longest possible string it can find of any word character. And you can see the word character. So it's finding the word XML followed by a space, version followed by equals, which is not a word character. So every time it hits something that's not a word character, which includes punctuation, which is not a word character, then it stops, and that's the end of a string of word characters, or a word in the simple sense. And so this is a very useful thing if you want to identify individual words, you want to tokenize your text, you want to take each word and do something to it. that sort of thing, this is quite useful. However, you may already have noticed there's a definition over on the right. What does \w actually mean? It means lower class characters are A to Z, upper class characters A to Z, 0 to 9 or underscore. You can see where I'm going, right? Because we've mentioned Greek already. Lower down in this epidoc file, there is some Greek. That is not being matched by that regular expression. Because, and I get to a bit where there's lots of Greek, because that is not between the letters A to Z, lowercase or uppercase, and underscore. That's a drag, that's the case. If you want to match Greek as well, you might have to do other kinds of weird things in there. For example, you might want to say, find me the range. Hang on, I need to be in the English character set to start typing this. So square bracket and plus. It's broken at the moment because there's nothing in there. And you might want to say alpha, omega, and bear in mind you need capital alpha and omega as well. And then, sorry, switch back to the English character set to type the hyphens. So find me any lowercase letter alpha to omega or uppercase letter alpha to omega. Great. Look at that for a few seconds. Something missing, right? It's not matching any accented characters in that string. Damn it. I do have a solution to that. It's not very nice, but this solution is based on knowing the order of the letters in the Unicode code points, and the order of the Greek letters is accented uppercase, followed by uppercase, followed by lowercase, followed by accented lowercase. Right. So that's for monotonic Greek. Let's pretend we're only interested in modern Greek at the moment. In that case, we can say, instead of saying alpha to omega, we could say, find me anything in the range of accented uppercase alpha. Let's see if I can remember how to type this. Accented uppercase alpha to accented lowercase omega. It's now finding all of the characters which are valid monotonic Greek characters, which is any character with an acute accent, in other words, as well as the unaccented characters. It's not finding all the polytonic characters, because what we've got here is, it's actually medieval Greek, but it's nevertheless, it's pre-monotonic, it's polytonic Greek. So if you're working on ancient Greek text, you need to be able to find grave accents, circumflex accents, iota subscripts, breathings, combinations of accents and breathings. So for that, I needed to go to the other Unicode code chart for advanced Greek, or extended Greek, I think it's called, in which I can see that code chart begins with alpha with a smooth breathing and ends with omega with an iota subscript. So I can put, now I really have to be sure I know how to do this. And so smooth breathing lowercase alpha to iota subscript uppercase omega. So that should now find me all Greek characters. Everything in the basic Greek range, accented uppercase alpha to accented lowercase omega, and the extended Greek range, which gives you all the polytonic characters, smooth breathing lowercase alpha to iota subscript uppercase omega. You understand why I say you don't really want to do this. But if you wanted to match all Greek characters, then this regular expression gives you them. And I don't think this is missing any Greek characters. It might miss numbers, characters like, copper and sampi and so forth that are used as numbers. It's missing punctuation, of course. It's missing the apostrophe in the middle of apauton, which it's reading as two words, etc. But which is probably correct. I mean, if we're lemmatizing, or we're tokenizing rather, we do want to consider app a separate word from auton. But nevertheless, this is bear in mind /w isn't going to help you find Greek, because it's expecting you're working on Latin text. And in fact, I don't know, given the definition, I'm not going to test this now, but given the definition that the regular expression 101 has given us, I would expect /W not to find accented Latin characters either. So if you're typing French or any language that uses lots of accents, I suspect that's not true, but I'm not going to test it. Let's leave it at that for now. Yes, Katie, you had another example of doing weird things with regex with Latin text.
Yes. So I have open in a different regex tester that can do the find and replace the text of Terence Hekaira that I've downloaded. And one thing that might be a problem with the Latin texts that you're working with are some of the spelling conventions. So things like, for example, whether you use the letter U or the letter V for the W sound. And what I've noticed in this text is that it's actually quite inconsistent. There's a bit of the text using one set of spelling conventions, there's a bit of the text using another set of spelling conventions. So I want to tidy that up. So I'm looking for U's and V's in intervocalic position or at the start of a word. Looking for these characters with particular things before and after them. So my first group is either preceded by either some sort of white space or word boundary. I'm going to use the white space here, or it's preceded by a vowel. So I'm going to list all my vowels, A, E, I, O, U. And then, okay, that's already found me everything following either a white space or that's a vowel. I'm looking for, let's find all of the uses of the U in this position. Obviously, it's got to be then followed by the second group, another vowel. Okay, so in this version of the in the introductory bit, all of the intervocalic w sounds are spelled with a U. In the rest of the text, they're spelled with a V. I want to tidy that up. I want my text to be consistent. So most of it's already a V. So I'm going to find all the U's in this position, and then I'm going to replace them here with this character, the V, replacing the U between the first capture group, so either preceded by a white space or a vowel, and followed by the second capture group, so followed by a vowel. I then here tidied it up. You can see the this version of the this introductory bit has fixed it so that the spelling is then consistent throughout the text. Okay, I'm going to just give this example, seeing that we're running a little bit over time. I'm now going to hand over to Jonathan. He's going to talk about regular expressions in Python, which works slightly differently to regular expressions in other languages.
Yeah, before we hand over to Jonathan, I've got a question, which is not so much a question for you to answer now, Katie, unless you want to, but a question that people listening, when they're thinking about exactly this change you've just made here, which is Y a vowel in Latin? I mean, in terms of what it does to a V, it might be.
Let me see if there are any, if this increases the number. Let me test this. So now that mostly V's, there's 371. Is there any difference? No, I think because the Y is basically only used in Greek borrowings, that's not a sequence you'd expect at all anyway. So I can't imagine ever finding a U and a Y in a Latin word.
Next one, yeah, that's probably the case. Yeah.
Yeah. So I don't think that would you'd expect to find that here.
It's good to know that
because we don't have the w sound in Greek at the period where there are borrowings into Latin.
Yeah. Cool. Okay. But it's the sort of question you might ask: what is a vowel when you're saying a, e, I, o, u? In some contexts, other things are. As if you were working in transliterated Greek, you might want to include H and W, which represent eta and omega, as vowels, for example.
Yeah.
I mean, if you don't work in transliterated Greek, that would be a terrible idea. But if you were, that would be something you'd have to.
Yeah. Or if you had a Latin text that did have a lot of transliterations of Greek words in it.
Cool. Okay. Sorry for that digression. Let's over to Jonathan.
Okay, so this is just a really quick demo of Python, and this isn't a Python session, so if you don't know any Python, don't worry. I think the main thing to concentrate on is that really the regex use is very similar with a couple of slight differences that I'll show you now. So what I've got here is a Jupyter Notebook, which is a nice way of running Python interactively, kind of line by line. You can run individual bits, and you can also have these commentaries around it. So I've got comments that you can see as well as code cells. So the first thing you always have to do in a Python script where you want to use regular expressions is to import the library. It's part of the standard library. So if you have Python installed, you will have this RE library. And now I can use regular expressions. And I'm going to do exactly the same as the first couple of things I showed you in Visual Code in the same file, except that because I've changed that file, I've got a separate copy, sample bibliography for python.bib. And I'll read that in with this little bit of code here. And what I've done is I've chosen a fairly arbitrary variable name called bib, which holds the text of the file we saw earlier in memory. So when I make changes now, I won't be changing the file in the text editor or on disk. I'm just changing it in memory, which is nice and safe. And if I want to keep it, I can then write it out later to a different file. So just to show you what's in this bib variable, I can show you that now. It's quite long, and it hasn't kept the line breaks. It's read everything in as one long string of text, but it's the same. I think you can see it's the same text as I was using earlier. So I've got this thing that doesn't work just because it's nice and simple. Doesn't work by default, but this is the way that you do regex substitutions in Python with this RE sub. And then inside the round brackets, you have two sets of quotation marks. Those are exactly the same as the find box and the replace box that I was using in VS Code. So you can see the first one I did was comma $. So same thing there. Because I'm replacing with nothing, those two sets of quotation marks are empty. And then the bib here is saying look in this string of text, which is in the bib variable. And at the beginning, I've got bib equals. In other words, I'm going to overwrite what's in memory in the original bib with the replacement version. So this will be changing in memory, and we can keep looking at it. But as I said, we're not writing anything to the actual original file. So if I run this, what I'm trying to do here is delete the commas at the end of the line. And from now on, I'll just show you the first 200 or 500 characters of this Python file, to make it easier to read. This is just a bit of syntax that says that character 0 to 200 in bib, or the first, which is effectively the first 200 of the file. And you can see this is one of the commas I wanted to get rid of. It didn't work. And that is because the regular expression is correct, but Python treats this whole thing as one long line. And so the $, I have here is actually the very last thing in the file. The very last character of the file would be $. So a comma at the very end of that bib file would be matched, but these in the middle, they're not actually at the end of a line as far as Python is concerned by default. So that's not very useful. So there is a way we can get around it, which is to use a flag called multi-line. So this is the same line of code here in 18, but I've just added on the end this bit, flags equals multi-line, and that treats the \n as being the end of the line which is what we want. So it's much more intuitive. I run that now and then look at the first 200. You can see it's gone from here, so it has worked. And then after that, it largely works the same way. So I deleted abstract in my VS Code example. That's exactly the same regular expression that I used earlier. If I run that, and then I'll show you 500 characters this time because the abstract is longer, and you can see it's gone. It's not there anymore. So it's working exactly the same way. Once you have this bit of code saved, you can run regular expression after regular expression and change things. And as Gabby said, you've still got your backup. You're not changing the original file. But as Katie mentioned, there are some little differences, and the main one I think you need to know about is in the back references. I was using $1 in Visual Studio Code. That's the standard. There's a sort of informal standard for regex called PCRE, which you'll see if you look at regex documentation, you'll see it quite a lot. That stands for Perl Compatible Regular Expressions. That's the standard most things use, but Python, for some reason, uses //. So when I wanted to trim the keywords line, which I did in VS Code, I did $1 here. All I need to do is to remember to do //1 to do that trimming, and it will have exactly the same effect. So otherwise, it's exactly the same regular expression, but the replacement is different. So if I run that, you can now see that I've trimmed keyword. It's stopping there, and it's exactly what I asked for, 30 characters. Just to show you, because you might be interested, in terms of finding things, the one I use in Python is find all, which finds all the examples of that regular expression in your text or texts. So here I want to find every line that has a title, all the titles in my text effectively. So I'm doing the same before, except there's only one set of quotation marks because there's no replacement. And it's again in bib, multi-line again, because I want to find things at the beginning of what are the lines in the text file. And here I'm reading it into a different variable called titles. So I'll run that. And then if I look in what's now in the titles variable, I've got the 8 titles that are in my bib tech, just those lines. So you can see how useful this would be to pull things out of text that you're working on. And then one final little bit, just because I said earlier that regex can be used in combination with programming languages, other facilities. So here I want to do a count just to find how many in titles. And because this is a list in Python, I can say what's the length of this list, and it will tell me the answer is 8. And then from that I can do more logic things that I might want to do with that list later. So if you learn regular expressions and then you learn a programming language, you'll find the two fit together quite nicely when you're working with text. So that's all I have on that. As I say, don't worry too much about it if you haven't done Python before, but I hope you'll see that the regex is actually pretty similar to the regex we used earlier. You're muted, Gabby.
So I am, thank you. Yeah, that's a really good example of how you can stack your various different regular expressions that you want to run across a thing. You can test them all one at a time and then in sequence, and then you don't actually run the whole thing until you've got the whole thing working. So you've got a whole sequence, and then you can test it on one file, and when it works, you can run it across your 2,000 files to do the bulk change. And assuming that they're all going to be compatible enough. So yeah, that's really useful. If you're interested in, I should make the text on this screen larger. If you're interested in looking a bit more closely at the Python that Jonathan just showed us, you may not be, but if you are, in the exercises section at the bottom of the session page for this, which again is linked beneath this YouTube video, there are 3 suggested exercises. The first exercise is the basic exercise. Work through the programming historian regular expressions tutorial, and then do some experimenting on trying to clean up some of the Greek or Latin texts that we looked at last week, getting rid of things like line numbers, chapter numbers, notes, annotations, whatever else from those texts. and keeping documentation of that. Then there's two optional exercises, which you can try. The first one is using these texts from the code and the Python notebook that Jonathan's just shown you in there, and those files are downloadable, although I don't see a link to download them in here in the exercise, so maybe we'll want to add that link in there shortly. So we can find that we have got those files in the repository, but we I think I don't see a link to them. We may have forgotten to put that in. So that's the second exercise, and the third exercise is if you want to use some slightly more tricky regular expression. If you think you're going to use this in future, it might be a really good idea to practice with something slightly more tricky rather than just finding square bracket, any digit, close square bracket. And so this is finding a sort of quite complex looking piece of text and code and extracting just a small part of that is the text you want to keep for processing later. And this actually will be quite useful for various exercises we might do towards the end of the semester. So that's another exercise you might want to try on. Whichever of these exercises you do, keep note of each step you made, what went right, what went wrong, what was difficult, especially when you find something that you can't work out how to do. Bring that to class and discuss that with people there. I'm sort of trying to talk simultaneously to my students, to whom I'm saying, come to class with your questions, and to anyone else in the world who might be looking at this. If you're doing this as part of a class, go to your next class with questions based on this. If you're doing it on your own, find someone else to help you, I guess. Anything else anyone else wants to add?
Just a note to say that the Jupyter Notebook, if you do download that, you'll need to install Python and Jupyter Notebook on your system, so that it won't just run as a text file, unfortunately.
Right. Maybe then, along with adding the download links for that, we should also add a quick explanation of what those are, instructions on how to find, Python or something like Jupyter or Anaconda or whatever that people might use to install that. That'd be useful. So watch this space. At some point very soon, a couple more lines will appear under optional exercise number 1, and that will be there. I should also note that the slides which have appeared on here since the session started, apologies for the very last minuteness of that. The slides contain links to both the cheat sheet that I showed and the Regex 101 site that I showed, we will, and those are also some examples there and under resources. But we can also add the other Regex tester that Katie showed. We could also add to this list of resources, and there may be some other things we mentioned that we can add to that list as well. So do come back to this page later. We'll enhance it. Cool. Okay, we're starting to. We were slowed down slightly by regular expressions being more complicated maybe than we factored in time for, but also by the internet issues that we had at various stages. But if anybody does have any questions, please do post them in the chat. We'll stay for a couple of minutes and respond to them if you do. There's I don't know what we fill the time with while we're waiting the promised couple of minutes. I guess I can sort of cast forward to remind us of what's happening in the next couple of weeks. Next week we're going to look at various approaches to Egyptian texts. This session next week won't necessarily expect you to understand any of the Egyptian scripts or languages, but we'll give you some sense of how to work with those texts. And there's an exercise based on looking at text and metadata in some of those main resources. And the session the week after is looking at digital editions of inscriptions of papyri. This is using the Epidoc scheme. I sneakily showed an Epidoc file in my regular expressions demo earlier. The Epidoc session is going to be using Visual Studio Code as our main XML editor, so it will follow on very much from what we're doing today. These are all on YouTube. If you found this session through YouTube, these are sessions that are also posted by the same by the SunoikisisDC user. If you're following this on via the Sunoikisys program, they're all linked from this program in here on the GitHub page. Final word on irregular expressions?
I think just to reiterate what we said, which is several times, which is practice. If it seems a bit difficult, everyone finds it difficult when they first start. It just practice with text that you know and want to work with, and start simple, and you'll find that you just get better at doing it over time.
Yes, absolutely. Yeah, I think, if you have something like the regular expression tester, the regex 101 or something like that, just starting by saying, okay, experiment with square brackets and what I put in them and what that shows up on the results before you even start thinking about replacing, just to get familiar with what these various shortcuts, shortcuts and various other codes mean, and and of course, as we've given a sort of very brief intro to it, which on the one hand isn't everything you need to know, but on the other hand is we told you more things than you really wanted in your first 5 minutes of regex. If we were giving you the entire course of regex, we'd have just told you about square brackets and question marks at the beginning and almost nothing else, and then you could have played with them for a little while. But if you work through things like the programming historian tutorial, there's a couple of other tutorials that we've linked to or that you can find elsewhere. They will also sort of break you in with exercises with the more straightforward things, and they can all potentially will also take you to much more advanced things than we've even hinted at here. You only need to go as far as you think you need to go. You don't need to. There will come a point pretty quickly when you know as much as I do, and there will come a point much further on down the line where you know as much as Jonathan or Katie do, and then I'm sure there is a point beyond that where you know even more than they do, because there's none of us are the most expert person in the world on this topic. So it really is fine to learn as much as you need, and then say that's actually what I need.
And I think as well, Gabby, that the more exotic stuff, you can just look it up anytime you need to use something a bit more unusual.
Yeah.
I mean, we all do it. You just look up the documentation or look online, and then type. And then it's just knowing that it can be done is the thing. You don't have to memorize all the little tiny details. Yes,
and especially look at those codes. I think if you the codes like /w and the other more advanced codes for sort of weird things. As we showed with a couple of examples, you can actually do a bunch of those things with the simpler regular expressions. You can do the /w code by saying, okay, I know it's an alphabetic character I want, so I'm going to say A to Z, capital A to Z. That sort of thing. So you can actually you'll end up writing much more complicated expressions, but without having to learn the more advanced sort of features. So if you prefer convoluted syntax to learning lots of new complicated codes or looking up lots of new complicated codes, you can probably do most of what you want to do that way as well. Okay, looks like we are out of time. We'll let people go. Thank you again, everyone, for joining us. Thanks to Jonathan and Katie for this session, and see you all soon.
Bye.